All right, this is example problem video 3B. This is for math heads, okay? Those of you that want to examine what this looks like if we treat it strictly algebraically, you don't have to be a math head. You could just be interested. All right, so basically what we're going to come up with is delta y is equal to, remember that v naught y is equal to v naught sine theta, right? And then we're going to multiply that by t, which, as you recall, is equal to delta x over vx, right? Actually, let me go back. Let's just do this as, let's substitute. We'll say that's v naught y times delta x over vx minus 1/2 g times delta x over vx squared, right? That's just substituting delta x over vx here for these two t's, right? Here's this right here, and here's this one right here. Okay, that's just for t. All right, now what we're going to do is go ahead and blow up these terms, this v naught y and this v naught x, and we're going to say delta y is equal to v naught sine theta times delta x over v naught cosine theta. It's already shaping up to be interesting. Minus 1/2 g times delta x. We'll go ahead and square that out. Delta x squared over v naught cosine theta squared. Okay? All right, so then we can simplify this to say delta y is equal to, the v naught y's cancel here, and then sine theta over cosine theta is tangent theta. So we could say delta x tan theta minus 1/2 g, or let's just make this a little simpler looking. We can say delta x squared g over 2 v naught cosine theta squared. Okay, so that's just, that's algebra teacher simplification. That's the kind of stuff you do in math class. Pretty straightforward. And then we just plug in all our stuff. And we get delta y. Now that we've arranged everything and got it to terms that we can just plug in numbers, we got delta x 124 meters times tan of 35 degrees minus 124, little dyslexia there, 124 meters squared times 9.8 meters per second squared divided by 2 times v naught, which was 37 meters per second times the cosine of 35 degrees quantity squared. Okay? Quickly, dimensionally, we're looking for meters, so let's just make sure, because we got a rather complex expression here. Let's take a look and make sure that we have what we're looking for, which should end up being meters. This one's easy. We got meters and dimensionless. That's just going to give us meters right here. Then over here, this is what's interesting. We got meters squared times meters per second squared. Gives us meters cubed per second squared. And here, when we square meters per second, we'll have meters squared per second squared. All right, so we can cancel out meters squared with meters squared, second squared with second squared, end up with meters. Hey, check it out. Dimensional analysis, what a wonderful tool. All right, so when we put all that stuff in, obviously, if math works correctly, which we hope it does, we would end up with exactly the same answer, and that's that delta y equals 4.8 meters. And I've done this both ways, and you do end up slight differences, as you move out past here where our precision would be false. So we get the same answer, 4.8 meters.